We're gonna do problem number 28.13 in the university physics textbook. So it goes like this. A long straight wire lies along the z-axis and carries a 4 amp current in the z direction. Find the magnetic field produced at the following points by 0.5 millimeters segment of the wire center at the origin. We're gonna do part A. So it says that at A, the x equals 0, x equals 2 meters, and then y is equal to 0, and z is equal to 0. Let's write down the information. He's saying that we have 4 amps, 0 amps, and that the segment is 0.5 millimeters, 0.000 meter up, 5 meters for the segment. Okay. And this was in the z direction and the z direction. Okay. So it's telling me to find, since it's saying that it's a long wire, then we are gonna just use the magnetic field, because if it didn't say it was long, then we'll use dB, but it's saying that it's long, so we're gonna use B. So it's mu sub naught for the formula over 4 pi times L currents times L cross R hat over R squared. And this can also be written like this, because we know that R hat is equal to R vector over R. Then we just substitute. Cross R vector over R. Third. Right? And we know what mu sub naught is. We got 4 pi already. We got the current, which is 4 amps. We just need to cross the L with the R vector. And the R vector, we use it with this points. The R vector will just be 2.0 I plus 0J plus 0K. So we just write it like this, 2.0 I. We cross it with this, because it was going in the z direction, the segment, so it's 0.0005 in the z direction, which is k, and we get 1.0 times 10 to the negative 3 meters squared. So we got the R vector already crossed, and we just plug in here. Okay, so we got that now. And then the R cubed, all you do is just take the magnitude of the vector, and the vector is this, the R vector is this, because the rest are 0. So the magnitude, to get the magnitude, you first square it, and then you take the square root of it, which in this case is the same thing because they will cancel, and so it's equal to just 2.0 meters. So we got this now. So we just plug in everything we got. is B is equal to 1.0 times 10 to the negative 7 Tesla meters per amp times the current, which it was 4 amps, times the vector that we crossed, which it was this 1.0 times 10 to the negative 3 meters squared. And then we just divide everything by the magnitude of the vector, which it resulted in 2.0 meters. And this is Q. So when we plug everything in, it gives us 5.0 times 10 to the negative 11 Teslas. And this is in the J direction. And the reason why is because when we cross in the vector, when we cross I with K, then you get J. And that's pretty much it. Alright, thanks.